Hi everyone, welcome to our physics class. In the previous classes, we have already studied speed, different types of speed, velocity, different types of velocity. So what is the meaning of speed? Speed is distance covered per unit time, the time rate of change of position without considering the direction. So what are the different types of speed? Number one, average speed. That means total distance covered divided by total time taken. So when a particle is said to be moving with uniform speed, if it covers equal distances in equal intervals of time. When a particle is said to be moving with non-uniform speed, if it covers unequal distances in equal intervals of time, or equal distances in unequal intervals of time, or unequal distances in equal intervals of time. What is the meaning of instantaneous speed? The speed of a particle at any instant of time. What is the meaning of velocity? Simply displacement per unit time. Displacement per unit time, or the time rate of change of position along a fixed direction. What are the different types of velocity? Number one, average velocity. What is the meaning of average velocity? So total change in displacement divided by total time taken. That is average velocity. So when a particle is said to be moving with uniform velocity, if it covers equal displacements in equal intervals of time. When a particle is said to be moving with non-uniform velocity, if a particle covers equal displacements in unequal intervals of time, or unequal displacements in equal intervals of time, or unequal displacements in unequal intervals of time. So what is the meaning of instantaneous velocity? The velocity of a particle at any instant of time, that is instantaneous velocity. Speed is a scalar physical quantity. The velocity is a vector physical quantity. Speed is always positive. Velocity can be positive or negative or zero. Speed having only magnitude, velocity having both magnitude and also the direction. So those are some very important differences between speed and velocity. So this is motion along a straight line, part 5. Okay, well, let's start today's class. Today we are going to discuss about the next a very important topic, acceleration. Acceleration of a particle is defined as the rate of increase in its velocity. It is very simple definition. The rate of increase in its velocity. For example, freely falling body. So when body, that is falls, body falls under the action of Earth's gravitational force of attraction. When the body falls under the action of Earth's gravitational force of attraction, actually that is called a freely falling body. Actually, this is an example for motion in one dimension. Is it not? So, what is the meaning of acceleration of a particle? Acceleration of a particle is defined as the rate of increase in its velocity. So when a body falls freely under the action of Earth's gravitational force of attraction, so if it is moving along this path, what happens to its velocity? Velocity that is gradually increases. So the rate of increase in its velocity of a body, the rate of increase in its velocity of a body, actually that is acceleration of the body. Okay. Suppose when the body that is thrown vertically upwards, when a body is thrown vertically upwards, so what happens to its velocity? Actually, its velocity that is gradually decreases at certain height. Its velocity completely becomes zero. Is it not? So when a body falls under the action of Earth's gravitational force of attraction, so its velocity gradually increases along this path. Okay, the time rate of increase in its velocity, that is acceleration, that is positive acceleration. So when a ball thrown vertically upwards, okay, when a ball is thrown vertically upwards, so what happens? Its velocity that is gradually decreases. Finally, it will become zero. Okay, rate of the time rate of change of decrease in its velocity, actually that is called the negative acceleration. The time rate of decrease in its velocity, that is the negative acceleration. The time rate of increase in its velocity, that is positive acceleration. Okay, so acceleration that is equal to increase increase in velocity, okay, increase in velocity divided by time taken, increase in velocity divided by time taken. Okay, so what is this? This is actually positive acceleration. Okay, so what is the meaning of negative acceleration? Negative acceleration. Negative acceleration. So this is also called deceleration. Negative acceleration or deceleration. This is also called retardation. Different names: negative acceleration or deceleration. That is also called retardation. Okay. So negative acceleration or deceleration or retardation. That means retardation of a particle is defined as the rate of decrease in its velocity. Okay, the rate of decrease in velocity of a particle, that is the retardation of a particle. The rate of increase in velocity of a particle, that is positive acceleration of a particle. So this is an example for positive acceleration. When a body falls under the action of Earth's gravitational force of attraction, so what happens? Its velocity gradually increases. The rate of increase in velocity of a particle, that is positive acceleration of a particle. So when a ball is thrown vertically upwards, what happens to its velocity? Its velocity gradually decreases. The rate of decrease in velocity of a particle, the rate of decrease in velocity of a particle, that is a deceleration of a particle. That is a retardation of a particle. That is negative acceleration of a particle. So negative acceleration, that is equal to decrease in velocity, okay, divided by decrease in velocity divided by the time taken. Decrease in velocity divided by time taken. Okay, what is the meaning of positive acceleration of a particle? The rate of increase in velocity, the rate of increase in velocity of a particle, that is actually positive acceleration, that is acceleration of a particle. The rate of decrease in its velocity, that is deceleration or negative acceleration or retardation of a particle. Okay, so after that, let us discuss about the different types of acceleration. Okay, let us discuss about the types, different types of acceleration, different types of acceleration. Okay, different types of acceleration. The first one is average acceleration. Average acceleration. Okay. So average acceleration, different types of acceleration. The first one is average acceleration. Before going to that, first let us discuss about uniform acceleration. Uniform acceleration. Uniform acceleration. So when a particle is said to be moving with uniform acceleration. So if a particle changes its velocity by equal amounts in equal intervals of time. Okay, so the velocity of a particle changes. The velocity of a particle changes by equal amounts in equal intervals of time, that is uniform acceleration. Okay, first here let us consider a VT graph. So this is a velocity time graph. So that means the velocity is taken along y-axis, a time that is taken along x-axis. So this is actually a VT graph. So VT graph means a graph drawn by taking velocity along y-axis, time along x-axis. The velocity is measured in terms of what is the unit of velocity, meter per second. Time is measured in terms of second. So after that, choose a scale. Okay. So x-axis, let us consider 1 unit. 1 unit is equal to 1 second. In y-axis, let us consider 1 unit is equal to 1 meter per second. This is actually 1, 2, 3, 4, and so on. This is 1, 2, 3, 4, and so on. Actually, this graph shows uniform acceleration of a particle. This graph clearly shows uniform acceleration of a particle. So, for example, if a particle velocity increases by 1 meter per second in 1 second, so then what is the position of the particle in this graph? The position of the particle in this graph, that is 1, 1. Is it not? and then again its velocity further increases by again 1 meter per second, and the time taken is same, that is 1 second. So then what is the position of the particle? That is 2 comma 2, and then velocity is increases again by 1 meter per second, so in the time 1 second. So then what is the position of the particle? 3 comma, and again the velocity increases by 1 meter per second. What is the position? That is 4 comma 4. So now join all these points, so we will get a straight line that is passing through the origin. So this graph clearly shows the velocity of a particle changes, is it not? So here velocity is not constant, right? The velocity changes. How? The velocity changes by equal amounts, because for every 1 second, the velocity of particle that is just increased by 1 meter per second. Okay, so here the velocity changes by equal amounts, that is in equal intervals of time. For every 1 second, what is the change in velocity? That is 1 meter per second. Okay, so when a particle is said to be moving with uniform acceleration, when a particle is said to be moving with uniform acceleration, if its velocity that is velocity changes by equal amounts, that is in equal intervals of time. Okay, so what is the meaning of non-uniform acceleration? Non-uniform acceleration means if its velocity changes by unequal amounts in equal intervals of time, or equal amounts in unequal intervals of time, or unequal amounts in unequal intervals of time, that is non-uniform. Uniform means the velocity of a particle changes. How? By equal amounts, that is in equal intervals of time. Okay, the velocity of a particle changes by equal amounts in equal intervals of time, that is uniform acceleration. Okay, the velocity of a particle changes by unequal amounts in equal intervals of time, that is non-uniform acceleration of a particle. And the next type, that is average 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 acceleration. Average acceleration. So average acceleration means it is actually the ratio of change in velocity to the change in time. Change in velocity to the change in time. Okay, now here let us consider 2 points on a straight line. Let us consider this point as A, this point as B. Okay, the point A corresponding velocity, that is the initial velocity of the particle, that is how much? 1 meter per second. And the corresponding time, that is initial time, that is 1 second. The point B corresponding velocity, that is the final velocity of the particle, that is how much? 3 meter per second. And the point B corresponding time, that is the final time. What is the value of final time? That is 3 seconds. Okay, so here we have to find out the average acceleration from this graph. So we have to find out the meaning of slope? Slope means the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. The ratio of vertical distance divided by horizontal distance between 2 points on a straight line. So A and B are 2 points on a straight line. So BC is the vertical distance between 2 points. AC is the horizontal distance between 2 points. So here slope that is equal to BC divided by AC, right? BC divided by AC. So what is the value of BC? BC is actually V2 minus V1. Is it not? BC is V2 minus V1. 3 minus 1. This is 3 minus 1. What is the unit? Meter per second. So AC, what is the value of AC? It is T2 minus T1. 3 minus 1. Is 3 minus 1 second. Okay. So 3 minus 1 is 2 meter per second. So this is 3 minus 1, 2 seconds. So 2 get cancels. So finally we will get 1 meter per second, that is meter per second square. Okay, actually the slope of this graph gives acceleration. Is it not? Meter per second square. So this is the SI unit of acceleration. Acceleration is a vector. Okay, so this point is also very important. Acceleration is a vector physical quantity because it is having both magnitude and also the direction. Is it not? Acceleration can be positive or negative or zero. This point is also very important. Acceleration can be positive or negative or zero. Acceleration can be positive or negative or zero. Okay. The positive acceleration of a particle means the rate of increase in its velocity. So negative acceleration of a particle means the rate of decrease in its velocity. Okay, what is the meaning of zero acceleration? Okay, so zero acceleration. Zero acceleration. So that means if a particle moving with constant velocity, okay, if a particle moving with constant velocity, so in that case, so change in velocity divided by change in time. This is the mathematical expression for average velocity, is it not? So if a particle moving with constant velocity, so what is the value of change in velocity? It is zero. If a particle moving with constant velocity, so what is the change in velocity of a particle? If a particle moving with constant velocity, what is the change in velocity of a particle? That is zero. Zero divided by anything is zero. So in that case, the acceleration of a particle is zero. Okay. So when the acceleration of a particle becomes zero, if a particle moving with constant velocity, a particle moving with constant velocity, then the acceleration of a particle that is exactly equal to zero. Okay, and the last type of acceleration, that is instantaneous. Instantaneous acceleration. That means the acceleration of a particle at any given time. Acceleration of a particle at any instant of time. The mathematical expression is A is equal to limit of delta t tends to 0, delta V divided by delta t. This can also be written in the form of delta V divided by delta t. Delta V means change in velocity. Delta t, that is change in time. So this is instantaneous acceleration. That means acceleration of a particle at one particular time, at a given time. Okay. So, or acceleration of a particle at any instant of time. That is the instantaneous acceleration. So, what is the meaning of positive acceleration? The rate of increase in its velocity. The rate of increase in its velocity, that is positive acceleration. The rate of decrease in its velocity is the negative acceleration. If a particle moving with constant velocity, so that is having zero acceleration. So acceleration, that is a vector physical quantity. It can be positive or negative or zero. So these are different types of acceleration. Uniform acceleration. So when a particle is said to be moving with uniform acceleration, if its velocity changes by equal amounts in equal intervals of time. So when a particle is said to be moving with non-uniform acceleration, if its velocity changes by unequal amounts in equal intervals of time. So what is the meaning of average acceleration? Average acceleration means the ratio of change in velocity to the change in time. So what is the meaning of instantaneous acceleration? Instantaneous acceleration means acceleration of a particle at any instant of time. Acceleration of a particle at any instant of time. So that is called the instantaneous acceleration. These are different types of acceleration. Okay. The next topic, that is position time graph. That is also called displacement time graph. So this is very simple concept. First here, let us discuss about xt graph of a particle at rest. Okay, so position time graph means position time graph. A graph drawn by taking position, that is along y-axis, and time, that is along x-axis. Okay, a graph drawn by taking position or displacement, that is measured in terms of meter, that is taken along which axis? Y-axis. Okay, and time, that is measured in terms of second, that is taken along x-axis. Okay, so what is the meaning of position time graph? A graph drawn by taking position along y-axis and time along x-axis. What is the meaning of displacement time graph? A graph drawn by taking displacement along y-axis and time along x-axis. Okay, so here let us choose a scale. First, x-axis. In x-axis, let us consider 1 unit is equal to 1 second. This is 1, this is 2, 3, 4, and so on. Okay, and y-axis, 1 unit is equal to 1 meter. Okay, this one is 1, 2, 3, 4, and so on. Okay, suppose a particle is at rest. So when a particle is said to be at rest, the particle does not change its position. The particle does not change its position with respect to its surroundings. Suppose the particle is at rest at a distance of 2 meters from the origin. So this is origin. So after 1 second, what is the position? At time t is equal to 0, what is the position? 0, comma 2. At time t is equal to 1 second, position will remain constant, right? But time varies. So after time 1 second, the position is same, that is 2. So this point is actually 1, comma 2. After 1 second, the position of the particle is that is 2, comma 2, right? And then 3, comma 2. After that 4, comma 2, right? So now join all these points. So this graph shows a particle is at rest. Okay, so here actually time varies, but the position of the particle, that is always 2 meters. That means the particle is at rest. When a particle is said to be at rest, if it does not change its position with respect to its surroundings. Okay, here time is variable, but the displacement, the position, that is always constant. So this graph clearly shows a particle is at rest. Okay, right? The next one, the next graphical representation. That is a particle moving with a constant velocity. Particle moving with a constant velocity. The particle moving with a constant velocity means when a particle is said to be moving with constant velocity, that means uniform velocity. If its displacement changes by equal amounts in equal intervals of time. Is it not? Actually here we will get a straight line that is passing through the origin. Okay, so this graph clearly shows a particle moving with constant velocity. Okay, so this is actually xt graph. Displacement that is taken along y-axis, time that is taken along x-axis. Okay. Okay. So this graph shows a particle moving with a constant velocity. So again here let us choose a scale along x-axis, 1 unit that is equal to 1 second. 1, 2, 3, 4, and so on. So along y-axis, that is 1 unit that is equal to 1 meter. So this is 1, 2, 3, and so on. What is this? Displacement. This is measured in terms of meter. This is time. It is measured in terms of second. This is time. It is measured in second. Right? So actually here the particle covers equal displacements, that is in equal intervals of time. So actually in this graph, slope is equal to 0. What is the meaning of slope? That is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Let us consider here 2 points A and B on a straight line. So what is the vertical distance between A and B? Vertical distance between A and B? There is no vertical distance, right? The vertical distance between A and B, that is 0. 0 divided by anything is 0. So here the slope of this graph is 0. But here slope is not equal to 0. Okay. So in this graph, Let us consider again 2 points on a straight line. That is A and B. A and B are the 2 points on a straight line. Okay. So what is the meaning of slope? Slope is the ratio. Slope is the ratio of vertical distance, that is BC, divided by horizontal distance, AC. Ratio of vertical distance divided by horizontal distance between 2 points on a straight line. That is the meaning of slope. So BC is 3 minus 2, 3 minus 2, 3 minus 2 meter. AC is 3 minus 2, 3 minus 2 second. Is it not? So actually, the point A corresponding displacement is the initial displacement 2 meter. The point B corresponding displacement is the final displacement, that is 3 meter. The change in displacement is x2 minus x1, 3 minus 2, that is 1 meter. So the point A corresponding time t1, this is initial time. The point B corresponding time, this is t2, so this is the final time. The change in time is t2 minus t1, 3 minus 2, so that is 1 second. So 1 divided by 1, so 1 meter per second. Okay. So after that, let us consider 2 more points on the same line. So now let us consider this point as A, this point as B. Again here we have to calculate the slope. What is the meaning of slope? The ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Okay, so this is the point C. Now what is the value of slope? Slope is equal to BC divided by AC. So BC is 3 minus 1, that is 2 meter, correct? AC is 3 minus 1, that is 2 seconds. So again we will get 1 meter per second. So here we will get 1 meter per second. Here is also we will get 1 meter per second. That means here the slope is always positive and slope is always constant. This point is very, very important. In this graph, the slope is always positive and constant. So slope of displacement time graph gives, what is this? This is actually velocity. Is it not? Slope of displacement time graph gives the velocity. So here what is the velocity? The particle is at rest. What is the velocity? Velocity is equal to 0. So in this graph velocity is 0. So here the velocity is constant. Is it not? Velocity is positive and constant. And next graph, that is a particle moving with increasing velocity. Particle moving with increasing velocity. That means the time rate of change of increase in velocity. So actually that is positive acceleration. So again here let us consider xt graph. Means displacement is taken along y-axis, time is taken along x-axis. So in this graph, actually we will get increasing curve. This is increasing curve. So here the slope is positive. Slope is positive, but that is not constant. That is variable. Because here slope of xt graph gives what? Velocity. Okay, here slope gives velocity, but that velocity is not constant. So the velocity is here variable, but here the velocity is constant. Actually here, what is the acceleration? The second graph, a particle moving with constant velocity means acceleration that is equal to 0. But here acceleration is positive. In this graph, acceleration is positive. Okay. Slope of this graph is positive and variable. So this is the graphical representation of a particle moving with increasing velocity. Particle moving with increasing velocity. The next one is particle moving with decreasing velocity. Particle is moving with decreasing velocity. Again, let us consider a graph. Okay, that means displacement is taken along y-axis, time is taken along x-axis. Okay, so here we will get the graph like this is a decreasing curve. What is this? Increasing curve. So in this graph, the slope is not positive, slope is negative, and again that is variable. Okay, so this is time rate of decrease in velocity of a particle. As the time increases, the velocity that is gradually decreases. Okay, slope of this graph is negative and the slope is variable. So here slope that is positive and variable. So in this graph slope is negative, slope is negative and variable. Okay, slope is positive and variable. Okay, so this is about the displacement time graph or position time graph. Okay, slope of displacement time graph gives which type of physical quantity? So that is actually velocity, right? Slope of displacement time graph gives velocity, right? Okay, thank you.